Okay, so we've been studying light and the way it bounces, the way it travels, refracts, bends, or waves in general. But now we're going to take a look at light specifically. And one of the things about light that most interests us is the way it, for instance, interacts with mirrors or goes through lenses, and how that can focus light or spread it apart. So what we want to look at first is the idea of reflectance. Reflectance is something that beam of light, let's say from this laser, okay, can go over and it can hit that object, this barrier here. And if I point it downwards, you're going to see there's an image that's out here of the reflected light. That's pretty strong. But if I look down here more, this is not a mirror, and so if you look closely at that area, it's sort of scattered. I mean, the light hits there and it breaks in all sorts of sections because the paper is kind of crooked, and so the light beams kind of come off. If I were going to draw that, let's say this light beam's coming in here to this, and then when it hits it, it kind of, some breaks off this way, some breaks off this way. Okay, and it goes all these directions. That's called specular. I'm sorry, that's just called a scattered reflectance. Now, if I turn this mirror around, or this object around, again, I can see where that dot is down here. Okay, and I'm going to move it right to where that point is. I'm going to flip this over. And what I'm going to see is, let's make sure that that point is right here at the end. Let's make sure this guy's coming right down through there. Perfect. Okay, what I see is that I've got, if I bend this mirror a little bit, I can see there's a strong dot here. And it looks a lot like what the dot would look like if it were here. That's a pretty good reflectance. As a matter of fact, if it's a mirror quality reflectance, it's called a specular reflectance. It's perfect reflectance. Now, what's interesting is if I want to show where this arrow this reflection goes, I'm going to take it like this. Okay, and that line is something like this. What we're going to notice is that there's a law for reflection, that what comes in, this looks interesting. It looks like it's kind of got some symmetry here. But if I take the line that's perpendicular out of here, I'm going to draw it with a black line. We're going to call that the normal, just like we did. I don't have a black pen, but I'll take this green pen. That's called a normal, just like it was when we studied forces. There was a normal force, and the normal force means anything that comes away from a surface perpendicular. Okay, so in that one, we're going to have this normal. A normal line, in this case, is the perpendicular to this mirror. And if we look, this angle in here should, as the law of reflection says, should be the same as that angle there. Now, if I took a protractor, I might have not drawn this perfectly, but ideally, it looks very similar. As I make that angle bigger, it's going to look more and more convincing. Any flat mirror is going to have, well, any mirror, if the light goes in, it's going to bounce off at the same angle. This is called the incident angle, okay? And this is called the reflected angle, incident and reflected, I and R. So the rule for mirrors is if light comes in and it's not exactly perpendicular to the mirror, it's going to come back out at the same angle it came in to the normal, and we're going to measure all these angles to the normal. So that's the law of reflectance.